Okay, so far we have learned about finding the slope function for different function, correct? Okay, the first one. If I have a constant, so A is a constant. So what is the derivative of a constant? What is the rate of change of a constant? Okay, Ideal, Aiman?
Yes.
Answer my question, please.
0.
Okay, 0. So that is the first thing you have to know. Okay, second thing, we know that if it is a linear term, like A times X, okay, what is the rate of change of a linear term? It is constant, am I right? Yeah, so what is the answer? Andy, Siti Haja.
A.
A. So this is what we have learned so far. So that means if I give you a question, the rate of change of e to the power of 5, what is the answer? Brandon?
0.
0, you are right. Okay, if I have pi x, so what is the answer? What is the rate of change of pi x? Kevin? Kevin Ng.
Yes, pi.
Pi. So this is using the first one. This one is using the second one, correct? Okay. Then we also learned that if I have a power term, A and N are constant, the base is a variable x. So what is the rate of change of Ax to the power of N? Cindy?
An x power n minus 1.
Yes. So everyone, you are familiar with the formula. Okay. So then the fourth one. So if I given you this to differentiate, okay. So what is the derivative for this term? X cubed times x squared. Esther? Esther?
Yes.
Yeah.
X cube.
Esther? Is this a single term like that?
5.
So I have to change it first, correct, Esther?
5x power 4.
Yeah, I have to put x to the power of 5 first. Yeah, then the answer is 5 times x to the power of 4. Thank you. Okay, then the last one we learned yesterday is talk about exponential term, am I right? The base is a e, the power is a variable x. So what is the derivative for this? Gladys? Gladys Wong?
Copy down the whole thing first.
Yeah, copy down the whole thing. Thank you for memorizing. Then after that?
Times the derivative of the function.
Yeah, of the power, okay? The power function. Correct? So you are familiar with all this formula. Now you try to do this question before I get into another one. Hurry up. 5 minutes. Okay. How is it so far? Two more minutes, eh? Okay, are you okay so far? Okay, can we start with part A? Okay, Javashini, can you tell me what is the answer for part A? So what should I write to the second term? How should I write second term, Javashini? This is something, yeah, yes.
Miss, the answer, right?
No, I don't want the answer. I want you how to rewrite this one.
Or 6/5,
6/5.
and then bracket 1/EX.
Okay, so this will be am I right? Do you write it like that, Javashini?
Yes, Miss.
Yes, okay. So can you tell me what is the derivative for the first term? What is the rate of change of the first term?
-6/5E negative X.
Why? First term. Yeah.
Sorry.
Okay, this one is correct. -6/5 e to the power -x. That one I agree, because you differentiate this term, you copy down the whole thing, then you time by the derivative of the power, so you get that. How about the first term, Javashini?
3E².
Okay, yes, you are right. 3, you multiply by the power. Okay, power take away 1. So you got that. So everyone got that? Kavan Ng, are you okay?
Teacher, for f prime x, right, I wrote dy dx instead.
Cannot, because I write fx.
Oh, okay.
So you have to see the notation that I use. Unless over here you write y equal to, then you can write dy dx. Are you clear?
Oh, okay.
Okay. B. Okay, so what I need to do, Johan, for B part 1. Johan, are you there?
Yes.
Okay.
You have to copy down the whole thing
So what I need to do, I put f prime 2. Understand?
Right. Understand.
Yeah. After that, what you do?
You replace the x with 2.
I replace the x with 2. Right?
Right.
So this answer is 3e. Okay, calculate. So this will be, you have to calculate manually. Yeah? This will be 12e. Am I right? Take away 6/5e squared. Okay, now, is this value greater than 0 or less than 0? Is this value greater than 0 or less than 0? Johan?
Greater than 0.
Yeah, because you divide by e squared. E is 2 point something around 3, correct? So 6 divided by 45. So 6 divided by 5 times around 3 squared. So this is less than 1. So therefore, it should be more than 0. Am I right?
Right.
Okay. So let's look at the second part. Okay, Avika, you owe me an explanation.
Yes, Miss. Sorry, Miss. I thought it was another class. Apologies.
So,
I thought maths was
so-
later on in the day.
so
I will go through the rules and catch up myself.
it's not a matter of go through the rule or catch up yourself. Okay. Please, yeah. Next time, make sure you that one.
Yes, Miss. Sorry.
Okay, number 2, part 2. Okay, Avika, since you came in, so what should I do with part 2? We have the gradient function already. So part 2, how should I write?
F. I'll make x equal to -2.
So I have to write like that first.
Yes.
So I put x equal to -2. Okay, so this will be 12e also. Take away. Okay, by the way, when you have this part, can I write this as? Can I write this like that? Avika?
No.
Why not?
Isn't it meant to be 6/5 e to the power e squared?
You see, this is e squared. So, yeah. So if I put here, because this is negative. So if I follow this, formula, I should write it as like that. Okay. I rewrite this. I follow my formula, okay? I follow the formula that I get. So this one I will get as 6/5, e to the power of negative, my x is -2. So isn't this is 6e squared over 5? Class, are you okay? So now may I know this is positive or negative? Can someone tell me? Is this positive or negative? Give some estimation. Can someone give me the estimation whether f prime negative f rate of change at x equal to -2, is it a positive rate of change or negative rate of change? Without using calculator,
Positive, Miss.
positive.
Yeah.
Okay, how you know it's positive?
12 minus around 6e power square is around 54. Divided by 5
Yeah.
is 10 point something.
Yeah.
12 minus 10 is positive.
So 6. So you get an estimation 6 times. Okay, E is 2.7 something, correct? Square. So this one, the highest it will be 9. Then you divide by 5. So you see, you compare this and this. So it's still greater than 0. So sometimes you must know how to do estimation without calculator. Are you clear, class? Okay, so this is so far what we have learned for the simple rule. Derivative, rate of change of a constant is 0. Rate of change of a linear term is the coefficient of the linear terms. Rate of change of power term, time by the power take away 1. Rate of change of exponential term, copy down the whole thing, time by the rate of change of the power. All right? Okay, so today we want to talk about another simple rule. That is the fifth, another simple rule that involves natural law.
Miss,
So, yes?
just now the greater than 0 is a must to put
No,
on.
no. I'm just based on this question. I try to teach you how to estimate on it.
Oh,
This is
okay.
not part of the answer.
Thank you.
All these are not part of the answer. Because I can ask the question. Okay, I can ask the question. Okay, find the gradient at x equal to 2. Hence, state whether the function is increasing or decreasing at this point. I can ask question like that. So if the gradient is positive, that means the function is increasing at x equal to 2 and x equal to -2 also. But the rate of increase at x equal to 2 is higher than at x equal to -2, correct?
Yes.
That is how we view at it. Because I can ask question. That's why I teach you how to estimate. Even without calculator, you should be able to estimate whether the value is positive or negative. Got it? So this is not part of the answer. Yeah. So you have to know that when I'm discussing in class, which part belong to the answer, which part is not, you should know for that particular question. I always will talk a bit extra. Yeah, that is how you learn more. Hello, class, can I move on? Okay, now we want to talk about natural law. Okay, simple rule for natural law. That means law na term. Okay, so when we say natural law, we have to memorize a few rules first. So the rule for natural law is like this. So the rule for natural law. Okay, first one, ln E, the answer is 1. Agree or not? So if I give you ln E, that means it's a constant. Even if I give you ln 2 ln E, this is also a constant. Yeah, so the answer is 2 because ln E is 1. Are you clear? You try to press your calculator and see whether you got 1 or not. Because the base and the index are the base and the number is the same, the ln, you will get result 1. Okay. Second, ln 1 is equal to 0. Okay, now you can use your calculator and test. Okay, the reason why ln E is equal to 1 because E to the power of 1 is E. Why ln 1 equal to 0? Because E to the power of 0 is 1. So that is how we get the natural log rule. Are you okay? Okay. Third, if I have a ln fx, whatever inside here, it doesn't matter. So I can rewrite this as this form. Are you okay?
Yes, miss.
So you have
I don't understand. I don't understand.
No,
Can you-
it's just sorry. This is A,
Yeah,
not N, okay? A. You just bring the power up.
Oh, okay.
That is how you work. Okay. 4. If I have a ln of a few function, fx multiplied by gx divided by hx multiplied by kx, for example. So whatever on top, you can break into many ln. On top, you plus. Below, you minus. I memorize like that. That is safer. You can break into, you got how many functions, you can break into how many long term. Are you clear? So you must have all this in mind first before I start to introduce you to the derivative of a rate of change of a natural log term. Are you okay? In the ln, if there is a rational function, whatever on top, you break, you plus. Whatever below, you minus. Only for multiply and divide. Hello? So, just to let you get used to the formula first. So if I give you y equal to ln e to the power x. Okay. So what can I do? Is it a long term? Or can I simplify this? Can I simplify this?
Yeah.
Yeah, can. Okay, let's ask our friend. Kiko. Paraki. Which rule I'm going to use to simplify it? So you see this rule?
Yeah.
Yeah, you can see from both sides. Depend on the situation. So Kiko, can I simplify this?
Yes.
Yes. Can you tell me how to simplify? I can bring this down.
Yeah, x ln bracket e.
So this will be x. Ln e, what is the answer for ln e?
Ln e is 1.
1. So if I ask you to find the derivative of this, can you?
Is it just 1?
Yeah, you are right. You see? So don't, that's why I say the most important rule for differentiation is like that. I have to ask myself first, can that be simplified? If can be simplified, I will try my way to simplify it. Before I continue. Okay, so if I give you this, sorry, So I don't straight away go to the rule because I want you to be familiar. You have to learn how to choose. Okay, now, is this a long term? Is this a long term? Nicholas?
Pardon?
How, this one,
Yes.
is this a long term?
No.
No? Okay, can I simplify this?
I don't think so.
You don't think so? Are you in my class yesterday?
Wait, let me think first.
Not let you think. It's not thinking, it's recalling. So I told you already. Without all this, it's like you without hemoglobin, yeah, without red blood cell. Nicholas, you are taking too long. No, Shazana.
Yes, Miss.
Yes. Can this be simplified?
Yes.
Yes. Can you tell me what is a simplified form?
Is this exponential term?
Yeah. What is a simplified form? It's exponential. I know. I give its exponential term. But this exponential term, I will not differentiate using the exponential term form first. I will simplify it first. So how to simplify it? Tedious?
E to the power of log x power 2.
So I bring this one up, correct?
Yes.
So next?
Then equal to log x power 2.
Are you sure?
Wait a minute.
You see? Young people. Did you memorize this? I tell you, you better memorize all this. If not, your SAT, yeah.
Become s squared.
Yes, this can be simplified. That's why you see your life, you have no time to do a lot of things. The reason is what? Because you live a very complex life. Not like me, I live a very simple life. You see, now I'm sitting at home. When I teach you, I know what to teach. I don't have notes with me, okay, by the way. That's simple. Okay, then the dy dx equal to
2x.
Yeah, 2x. So you see, simplify is so important. Okay. So now I want to teach you how to differentiate a natural log term. So remember this formula. So the rule is ln, there shouldn't be any power. Yeah. So it's ln fx. It shouldn't be any power here. Okay, if I have a. So the answer will be a. It will be a fraction. Understand? It will be a fraction. Down there, you write fx. Up here, you write the derivative of fx. So that is how you differentiate natural log term. Condition, this is just a function without the power. And there's no product, no quotient for that. If I got given this, then what should I do? I will tell you later. Class, are you okay?
Okay.
Okay. So don't think everything will learn, then I will use this one. No, depend on the situation. I show you the two situations already. Are you okay, class? The first rule, simplify. Okay, can we go to the example? Memorize the rule for natural log term already, huh? Okay. We'll go through the example. Okay, now. So all these are finding dy dx, huh? So I give you, okay, fx equal to ln 1 minus 3x squared. Okay. Okay, I ask you to find the gradient at x equal to, okay, can someone give me a suitable value for x for this case? Can someone give me a suitable value for x for this case? Hello? No one? No one there to give me? Safan? Saf1?
Yes, miss.
Yeah, can you give me a suitable value for x?
2.
2 ah?
Hmm.
Sure.
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 2 ah?
Ah.
2 can. Okay. I write it in this form, correct? I told you already, this one shouldn't have the power, correct? So I can bring the power in front. For ln, domain. Can I use 2, Safan?
Oh, no.
Hmm.
Negative 2.
So you forgot everything Mr. had taught you. So what is it? Negative 2. Yeah, negative 2. Okay,
Yeah.
so we do for negative 2. Okay. So very naughty teacher, huh? Okay, but I'm telling you, that's why every time when you look at the question, you should know whether the teacher said the right question or not. Yeah. So what we do is, so first we have to find the derivative function. So I told you already, it shouldn't have any power. So whatever inside here, this is your fx, okay? Class? Okay, so now f prime x. Okay, Safan, can you remember the formula? How to differentiate an natural log term?
Differentiate the fx, right?
So what? Get ready first. It's a fraction. So you see, success
So-
are for those who get prepared. I prepare first. Okay, so
So
what to put down there?
for the numerator, -3.
Okay, let's go to the formula.
F prime x.
Numerator is f prime x. Denominator?
Fx. So 1 minus 3x.
Yes. So we got this -6/1 minus 3x. So therefore, f prime -2, we sub in okay, so we got -6/7. Are you okay? Class?
Yes.
Yes. Okay, let's try another one. Okay. Okay. Number 2. Given.
Wait, miss, can you go back for a second?
Yes. Any question?
Hey,
No,
teacher, actually, how do you get like -3 up there?
How do I get -3?
Yeah.
Young man.
Yeah.
Up
Sorry.
here, up my fx is 1 minus 3x ma. So what is f prime x? Derivative of 1 is 0. Derivative of -3x is -3. So I got -3. That is how.
Oh, okay. Thank you.
Okay. Okay. You better ask now then. During exam, you don't know what to do. Okay. So can I go to the next one?
Yeah, I can.
Okay. So I say given gx is equal to ln x square times 5 minus x cubed divided by x plus 2 x plus 1 to the power of 4. Okay, so you see inside ln is very complicated, correct? So I ask you to find the gradient function. Okay, so in order to do this, we must remember the formula to break the ln. Okay, ln A times B over C times D. This one can break as ln A plus ln B minus ln C minus ln D. And we have to remember that ln A to the power n can be written as n ln A. So you apply the two formula and simplify the whole thing for gx first. So that is for ln. Yeah. So gx, you have to simplify it. So I write down ln x squared. So the next one. Next one, Sarafina. Next one. Should I put plus or minus?
Plus.
Plus.
5.
Ln 5 minus x cubed. Am I right?
Yes.
Then next one.
Minus ln x plus 2.
Some more.
Minus ln x plus 1 to the power 4.
Okay. So can I straight away differentiate?
No.
No, I'm not going to. It's not cannot, can, but I'm not going to. So I'm going to apply the second formula. 2 ln x plus 3 times of ln 5 minus x. Take away ln x plus 2. Take away 4 ln x plus 1. Okay, now am I ready to find the derivative for each term? The answer is the yes. So I write down g prime x. Okay, so what is the derivative for the first term? Shivani?
2.
2. Sorry, 2. Get ready. What should I put down there, Shivani?
Fx.
So what is my fx in the first term?
Ln x.
My fx is 1x, yeah? So what should I put on top?
Ln, I don't know.
Hey, how can you say you don't know? What is the derivative for x? What is the rate of change of x? It's 1.
1, right?
Yeah. Okay, plus. You try the second one.
3 5 minus x.
Up there?
1.
1. You see the negative sign?
-1?
Yes. You are right.
Okay.
Take away. Okay, hold on. I want to call someone to do. Kevin.
Bracket.
Bracket.
Then numerator is 1, then over x plus 2.
Clever, lo? Why numerator is 1?
You derivative of x is 1.
Correct. Take away 4 bracket. Kevin?
1 over x plus 1.
Yeah. You see, Anna? Class? That is for natural log. So, if you want, you will write as. You don't have to make it to one single fraction because this is too many already, okay? So, wait, this is x
Wait,
plus
miss?
2.
Oh, yeah.
X plus 2. I know, I realize it. Okay. So, are you okay? Class?
Miss. Okay, miss.
Okay, so let's try the last one. Okay.
Miss?
Yes?
For the previous one, don't you have to further simplify it?
Which one?
And this one, don't you try and make it into one fraction?
No, no need. You don't have to make it to one single fraction.
Okay, thank you.
Too many already to do that. Yeah. Okay, so let's start with the next one. Okay, given y equal to okay. Okay. Start. So what is the answer for the gradient? Zafan? Zafan, what is the answer?
1 plus 1 over
What is the answer?
I got 1 plus 1 over x non-bracket 5.
So what is the answer? I want the final answer.
Oh, yeah.
You got, have you sub in the x equal to 2?
Not yet.
The answer is 2.5. Anyone got the answer as 2.5?
Yes, miss.
Okay. So this bound down to the same thing. I can do mentally, I get the answer already. Okay. So I don't expect you to be as fast as me. If you can be, that will be much better. Can you? Can you do as fast as me? Huh? Justin? Justin, can you do as fast as me?
Maybe.
Can. You should be able to, because at higher level, you can anytime be faster than your teacher. If you are familiar with the simplification. Okay, so Justin, can you tell me that when do you start to differentiate or you simplify first? Justin?
First.
Yeah, so the first term, E ln x. Okay, I write down first. Okay, so E ln x, how you simplify it, Justin?
X.
X plus ln EX.
X ln
X. Ln E. Ln E is 1, correct?
Yeah.
So you plus ln 5 x. So this will become simple as 2x plus ln 5x. People can give you something that is very difficult. Why? I can simplify it because I know this. E ln anything? Ln EX is x ln E. This is 1. So then only I start to differentiate. So that's why I say simplify is the key for all. Yeah. Are you clear? Everyone?
Yeah.
So this is 2 plus. So get ready. Here is 5x. Up here is 5, correct? So actually, this is 2 plus 1 over x. Do you know why is it like that? The reason is because next time if I see this, actually this can be written as ln 5 plus ln x. Am I right? Ln 5 is a constant. You differentiate a constant, you get 0. So this one you get 0, this one you get 1 over x. So I sub with 2, so I got 2.5. Am I right? Okay, class, simplify is the key. So please memorize all the formula. How to simplify. Can or not?
Sorry, teacher, can you explain why 1 over x again? The ddx ln x one.
Huh? Kevin, you tell me how you differentiate ln?
You differentiate x is 1, right?
Yeah, lor.
But then why is it 1 over x? Oh, okay, no. Sorry.
Ah. Kevin, you should. Next time, if you ask the question, or you think twice first. Don't be too quick. You think first, then you can learn better.
Okay. Sorry,
okay.
teacher.
No, when the way why you are so, because you are wondering, so you ask yourself this question. Okay, how should I differentiate long term? So you go back to this formula. So every time you don't keep asking how you get the answer, you ask yourself, how can I get the answer for derivative for long? Then that way you can learn. That is the formula. Oh, now I know why my teacher put X there. Why my teacher put? Because I follow this formula. Okay, so this is the X I put down here, then I put up here. So I always put the down first, then only put the up. But you see, just now when you do the other way around. That's why you will fumble with your formula. I will put down there first because the down one will determine the top. That's why sometimes the order of putting in the value in the formula, correct? You better follow the teacher's order because we know already that order will lead you to the right answer. I will not put the top first. I always put the bottom first. You get me? Because the bottom one will determine the top. It's not the top determine the bottom. So you have to know the determinant. Whatever in the law, I have to put down there. So whatever I have down there, that will affect my value in the numerator. So numerator have to write last. That is the order. That's why sometimes when doing maths, right, the order, you try not to change it. You change the order, you cannot get the answer. You get me? Okay, class? Thank you.
Thank you, Miss.
Thank you, Miss.
Thank you,
Thank you,
Miss.
Miss.
Miss,
Yes.
for the final answer, right? Should we can we express it as 5/2 or we need to express it as 1/2?
Okay, what do you think?